hand trick is going to help you basically with the coordinates on the unit circle. So one thing that you still would have left to make sure that you know would be the angles in degrees and the angles in radians. Those are things that you'll be studying around the unit circle. And the hand trick is really going to help you with the first quadrant, okay, the positive quadrant, quadrant 1. So what you're going to do, I take my left hand and I look at my palm. So take your left hand and look at your palm. Okay. Your pinky is going to be the horizontal x-axis, so that would be 0 degrees or 0 radians. Your thumb is going to be the vertical axis, 90 degrees, or I'll practice in radians because those are usually the angles we're less good at, pi over 2. Okay. And what does that mean your 3 other fingers are? 30, 45, 60, right? So your ring finger is pi over 6, your middle finger is pi over 4, and your pointer finger is pi over 3. Okay, in order to be able to use the hand trick to do the coordinates, you need to remember this piece, that it's the square root of the number of fingers over 2. For both parts of the coordinate, for the cosine and for the sine. Okay. In terms of cosine and sine, remember cosine is like your x-coordinate and sine is like your y-coordinate. I always remember, just like x, y comes in alphabetical order, cosine, sine comes in alphabetical order, right? Okay. Cosine is going to be the fingers, I say, on the left. And sine is going to be the fingers on the right. Okay, so we're going to start with the 30-degree angle, or pi over 6, which is your ring finger. So when you want to get the coordinates for that angle, put your angle away. So I'm taking my ring finger and put it away. Okay, so I'll do that on the board. I'm just going to squiggle out this finger. Okay, how many fingers do you have to the left of pi over 6 now? 3. So the x-coordinate is the square root of 3 fingers over 2. How many fingers do you have to the right of pi over 6? 1. So it's going to be the square root of 1 over 2, which is just 1/2. Okay. Now, let's put 30 degrees back out. Put away pi over 4. That's your middle finger in, not out. Okay, all right. So, for your x-coordinate, how many fingers to the left? 2. So the x-coordinate is square root 2 over 2, and the y-coordinate is square root 2 over 2. Hopefully you have 2 fingers left. Okay. If you want to do the pi over 3, or the 60-degree angle, put away the 60-degree angle. Cosine is, wow. Yes. If you put away the pi over 3, how many fingers do you have to the left? 1. So it's going to be 1/2 square root 1 over 2. And then how many fingers do you have to the right? 3. So square root 3 over 2.
Actually did a pretty good job.
And I skipped 0 and pi over 2, but it works for those quadrantals as well. If we were to do pi over 2, put away your thumb. How many fingers do you have to the left of your thumb? 0. So square root of 0 over 2 is just 0. How many fingers do you have to the right of your thumb? 4. Square root of 4, 2 over 2 is 1. Look at my coordinates. Okay, and it works down here as well. For 0, you would come up with square root of 4 over 2, which would be 1, and then 0 over 2. So if you have a hard time, I think this can be especially helpful for some people when they're doing the 30 and the 60 degrees, because that's the one when you're doing the unit circle that you most often flip those around. So if that makes sense to you, if you're a person who likes to use your body as you learn things, you can use the hand trick. Okay, if you're like, that was really confusing, I have no idea what happens, you can ignore the hand trick and you never have to use the hand trick again. Okay. I like to use the hand trick as well to do things, like I'm really good with unit circle now because I'm doing it every day, 5 times a day or whatever. So I'm awesome. But if you ask me in October what the sine of 60 is, I might just pause momentarily. I might put down my 60 degree and I might say square root 3 over 2 then. Okay, so I use it like this. I will put away the 60 degree angle. The left would be cosine, the right would be sine, so then I have 3 fingers left, so that's square root 3 over 2. So I like to use my hand trick. I can also see all the triangles, so like I have other methods because I've done unit circle for so long, but for a long time I really enjoyed the hand trick. Now, I didn't know this until like 2 years ago, but there is a way to do tangent with the hand trick. So if you really love the hand trick, I'm going to just real quickly model the tangent for you. Let's say we wanted to do tangent of pi over 3. Okay, so same thing, put pi over 3 away. Okay. And then here's the difference of tangent. After you put down the angle, so we put down pi over 3 already, then you flip your hand, and it's the square root of your fingers over the square root of your fingers. So the tangent of 60, remember we got our pointer finger down because this was, we flipped it, right? So how many fingers do you have to the left? 3. So it's the square root of 3 over how many fingers do you have to the right? 1. Square root of 1, which is just the square root of 3. And sure enough, that's the tangent of 60 degrees.
Who came up with this?
I don't know, but wasn't it amazing? Okay.
Where was this?
I guess, thank goodness we have 5 fingers. What if we only had 4? What if we had 6? Then it wouldn't work.
Cut one off.
The mysteries of the universe right here.
Borrow one from a neighbor.
Now, I've never done this in a class where like maybe someone didn't have all their fingers, and I thought about that this morning. Like, would they feel excluded?
Well, they have
And
another hand.
Yeah, I guess. I don't know. You can't. I guess you could look at your right hand like this. Oh, I would feel bad. I gotta watch next year if everybody has all their fingers. Nope. So. Well, I don't want to like leave. I don't want to like exclude sign.
Like Jeremy only has 8 fingers.
Okay, we're gonna take notes over 4-4. So now we're gonna switch gears. You know what? All week when we're doing notes, it's probably a good idea for some of us to keep our unit circles out on our desks, especially if we're feeling like not as ready for unit circles as we should be. So leave your unit circle out. That way you can refer to it when you need to. This set of notes in particular is a little bit strange because I'm going to go over what a reference angle is, how to find a reference angle. We'll do a couple of examples, but then when we actually get into like the real work of like evaluating trig ratios with reference angles, essentially we're going to be doing them on the unit circle, and the reference angle is already done for you on the unit circle. So then it's like, okay, then ignore reference angle for a little bit and just look at your unit circle. You'll see what I mean when we get to that second half of our notes. Now, one really important piece of the definition for a reference angle are these 2 adjectives for your reference angle. Your reference angle should be positive, and it should also be acute. So essentially, we're always trying to match it up to an angle that sits between 0 and 90 degrees, something in the first quadrant, positive quadrant. Hopefully, you've seen this notation, theta prime. Okay, so it means not the original angle, but the reference angle. Anytime we see theta prime, we're going to talk about a reference angle. And then the reference angle is formed by the angle's terminal side and the horizontal x-axis. Now, it could be the positive x-axis or it could be the negative x-axis. It's whichever side of the x-axis gets you an acute angle. something that's less than 90. Okay. So essentially, we really use reference angles for angles in quadrants 2, 3, and 4. If an angle is in quadrant 1, most of the time it's probably already positive and already acute, like 30, 45, 60, 50, 15, whatever. If you had an angle, there are other angles that could live in quadrant 1, like let's say 380 degrees. Well, its coterminal angle, 380 minus 360 would be 20 degrees. Bam, that's the angle, right? I don't need a reference angle in quadrant 1. So this is used in the other 3 quadrants. If you like a visual representation of a reference angle, here's what we're talking about. So you could draw any angle in quadrant 2. Okay, so I'll kind of highlight my angle in blue here. I've got an angle in standard position, so I have a positive x-axis for my initial side, and then I want it to be somewhere in quadrant 2, so I just put the terminal side out in quadrant 2. Okay. And we're just going to talk about a basic angle theta. Okay, so it's opening counterclockwise is positive. The reference angle is this smaller angle over here on the left. It's formed by the terminal side of theta, so that's the side that ended in quadrant 2, and the horizontal axis. Well, I don't want to go back to the positive axis because that's obtuse. So I want to come to the negative x-axis, and there's my theta prime. And you could draw a similar picture in the other 2 quadrants if you wanted to. So here's one in quadrant 3. Okay. Again, it doesn't really matter where your terminal side is as long as your terminal side is somewhere in quadrant 3. That's your theta. Okay. And then your theta prime, your reference angle, is the terminal side and the horizontal x-axis. That bigger so you can see it. And then of course there's the last one. This time I'll just highlight my reference angle. Terminal side in quadrant 4 goes back to the positive x-axis now. Okay, that gives me a positive acute angle theta prime. What I want you to do, and you may recall this from Algebra 2, is have a quick chat with your pod members. You might know it from Algebra 2, or you can come up with a plan just by looking at the visual here. Suppose you knew an angle in each of the 3 quadrants. So if your group is having trouble, pick some value in quadrant 2, like theta is 100. How do you calculate the reference angle in quadrant 2, in quadrant 3, in quadrant 4? And think about it 2 ways: degrees, radians. So in the end, you kind of have like 6 shortcuts for finding reference angles. See what you and your group can come up with. Go for it.
Yeah.
If we have 180, we want to here.
Yeah.
From the angle.
We
Yeah.
take the whole thing and subtract this to get that. And then of course 360 subtracts.
And the last one is subtract.
Then of course
Use sides. Pi.
pi minus 7. Theta minus pi. Which is the only one that starts with theta.
You said the angle minus 180 for quadrant 3.
Okay, conversations are kind of dying down here. Let's write down some ways that we could calculate the reference angle for both ways to measure angles, degrees and radians. So if we're in quadrant 2, a good way to think about it is give theta a value, right? Like 100. If you knew that the red angle was 100 degrees, how would you calculate the value of the green angle, the reference angle? Subtract. And in which direction would you subtract? Like you would do, what would you subtract? 180 minus 100 or 180 minus the angle. Some people might look at that from a very geometric perspective as well. Those two angles, the red and the green, or the blue and the green there, they are linear pair. So they are supplementary and they add to 180. If you have one angle in a linear pair, just subtract it from 180 and you have the other angle. You can easily figure theta prime in radians just by making a substitution. What is equal to 180? So if you ever were working with a radian in Algebra 2, some people's go-to response was change it into degrees, do my work, and then if I have to change it back into radians. We want to now keep it in radians and just work in radians, pi minus theta. Okay, what changes in quadrant 3? Let's say I have an angle in quadrant 3. It's got to be over 180, so let's say it's 200 degrees.
It's the angle minus 180.
Then it's going to be the angle, subtract 180. I like to think about that one in a visual perspective as calculating the overflow. So it's like, I had more than 180 degrees. How much more did I have? Get rid of quadrant 1 and 2, so subtract out that 180. And of course, in radians, that just means theta minus pi. So anytime you're going back to the negative x-axis on the left there, you should be using the value of 180. What value should we use for the positive x-axis on the right? Instead of 180? 360, because we want to make a whole circle, don't we? The red angle and the green angle make a full circle of 360 degrees. So theta prime is 360 minus the angle that we know. Oops. Getting my zeros and thetas mixed up. 360 minus the angle that we know, or 2 pi minus theta. Now, I do have to put a small disclaimer on these statements. These rules, theta minus 180, 360 minus theta, those types of things, these only work when theta is between 0 and 360 degrees, or 0 and 2 pi radians. So this really only works if your angle is within one positive revolution. If your angle is negative or your angle is more than 360, just use what we learned early last week, coterminal angle. Add 360, subtract 2 pi, whatever you have to do. Get it between 0 and 360, and then you can use this rule. Now you'll see this notation a lot where 0 is included, but 360 and 2 pi are not. That's just because they're the same angle. So we always include the smallest one, 0, and we leave out the big one. So if you say, oh, that angle is 360, you would really call that angle 0. That's your answer. Okay, so I'm going to give you 2 problems to try with your groups. These are good because you're going to practice sketching angles and then also finding the reference angle. And I picked 2 that were a little bit more challenging because I'm not giving you thetas that fit in my green inequalities. So you and your group members will have to figure out what the heck you're supposed to do. So give you a little bit of time, sketch the angle and find its reference angle. yeah. And we run the online quiz. For some of us, the hardest part of this may just be sketching the angle, but that's good practice for us. Be comfortable with our angle measures.
Oh my gosh. Wow, holy
Call me over if your group has a major question. I would love to answer it.
Oh, I see. I got you. I lost myself in the church. I keep buying the same Christmas That's the one I did it.
Okay, I'm going to go ahead and kind of walk through like some things that I'm thinking about when I'm tackling both parts of these problems. So remember, there's two things you got to do. Sketch an angle, find a reference angle. So I'm going to do the sketching part first. Now, I usually sketch an angle as I see it. So that first one is negative 600 degrees. I'm thinking about the fact that it's going to be going clockwise. And because it's negative 600, it's going one full revolution at least. So negative 360 is one full revolution. If I do another one, that's negative 720. So I'm somewhere in between 1 and 2 revolutions. Okay. So what I usually do in that case is I go ahead and I mark my last full revolution. So like this is negative 360 if I were to go around one time. And then I just add up by negative 90s. I just label my other quadrants until I figure out where it goes. So this will be negative 450. This will be negative 540. Oh, I can tell it's probably going to be here in quadrant 2. If I add another negative 90, that's negative 630. And sure enough, that's where my angle belongs. So I'm going to put my terminal side in between negative 540 and negative 630. And then to sketch the angle, I should have the full revolution, negative 360, plus what it takes to get to negative 600. So it looks like that spiral. Okay. If I want to calculate then theta prime, visually I could see theta prime as this angle right here, okay, from the terminal side to the horizontal x-axis. And we know that in the second quadrant, that would be 180 minus theta if we're working in degrees. But the issue is I don't want to do 180 minus negative 600. That's obviously not going to give me an acute angle. Okay, so I'm in 80. So what I want to do before I calculate a reference angle is do the work for a coterminal angle that sits between 0 and 360. So add 360. I'm not going to be between 0 and 360 yet. Add 360 again, so that's really negative 600 plus 720. That's 120 degrees. Then I can do theta prime equals 180 minus 120, which is 60 degrees. Okay. If you're looking at your unit circle, you might also recognize, like, if you look at your 120 degree angle on your unit circle, whatever color you highlighted that butterfly, that's its reference angle. So if you look at whatever butterfly color you chose for 120 degrees, it should be the same for 60 degrees and quadrant 1. Okay, so they're part of the same family. They're the same reference angles. The reference angle work is all done for you on the unit circle. That's amazing. Okay, all the way around. Okay, for 11 pi over 3, I'm going to think about this with radians. Now it's positive, so it's going counterclockwise. 1 revolution is 2 pi in radians, and if we were looking at a denominator of 3, that would be 6 pi over 3 would get me to 2 pi. So I'm going 1 full revolution, and then I would just think about it like this. If I went around again another 6 pi over 3, then I'd be at 12 pi over 3. So 11 pi over 3 is probably close to 12 pi over 3. I'm thinking it's probably in the 4th quadrant. If you were not yet convinced, you could label some more of these. Like from 6 pi over 3, if you just add 1 pi, that'll get you to 9 pi over 3. This is 2 pi, this is 3 pi. And then what's exactly in between 9 and 12? 10.5. So I can figure out what that quadrantal angle is just by splitting it in halves and fourths, okay, if I need to, which confirms it is in quadrant 4. And this one was counterclockwise because it's positive, so I go 1 full revolution and then some. If I want to do the work to calculate the reference angle, again, I don't want to do, what's this one going to be? Theta prime equals 2 pi minus theta. But I don't actually want to use this theta because that will give me a negative answer. So I'm going to do coterminal work. Okay. So I'll go back up here. I'll just subtract 2 pi, which is 6 pi over 3. That's 5 pi over 3, so that's between 0 and 2 pi. And then theta prime is 2 pi minus 5 pi over 3. That's just pi over 3. Now again, I know radians are like not everybody's favorite things, but if you never work in radians, it never gets any easier. Like every time you see it, you'll be disgusted. So just give it a shot. Try it, right? You're going to work with fractions. It's going to build some connections there to fraction work, and it's a good thing. Now, some people may know from Algebra 2, you maybe had this discussion. If it looks like 11 pi over 3, then its reference angle is pi over 3. If it looks like 21 pi over 4, then its reference angle is pi over 4. If it looks like negative 213 pi over 6, then its reference angle is pi over 6. Okay, now that only works for certain angles. It works for the angles on the unit circle, which is awesome. Pi over 6, pi over 3, pi over 4. It doesn't work for angles like things that are over 5, if you were looking at something not on the unit circle, because in quadrant 1, there's 2 pi over 5 and 2 pi over 5 are in the same quadrant. And so you wouldn't be able to say which acute angle it is. But ours are separate, so we can do that. Okay, now, that's all the work for reference angles. We're going to switch gears, and we're going to calculate trig functions without a calculator. So think about Friday's quiz, no calculator. It will also be no unit circle, but you'll have the knowledge of the unit circle in your head, okay? It'll be there by Friday. So if we want to evaluate secant of negative 480 without a unit circle, here's what I'm going to do. I need an angle on the unit circle. So if it's negative 480, I'm going to do what? Find coterminal angle that matches one on the unit circle. So I'm going to add 360. Well, that's going to get me to negative 120. Add 360 again, and now I have the secant of 240 degrees. Okay. go over reference angle, and then I'll use my hand trick here in just a moment. But this, ideally, to streamline your whole process, once you have the knowledge of the unit circle, you would be like this. What is the coordinate at 240 degrees? And if you want to look at your unit circle, look at your unit circle. What is the coordinate, xy, at 240 degrees? I think it's in quadrant 3. Negative 1/2, thank you, Bayla, and negative radical 3 over 2. And we know from last week, the x is always cosine and the y is always sine. So if you know the unit circle, you know cosine and sine of 240. If you want to do the secant of 240, that's the reciprocal to cosine. So we just have to flip negative 1/2, which would be 2. I'm done. Okay, if you couldn't remember your unit circle, okay, worst case scenario, you would do reference angle. 240 is in quadrant 3. To get its reference angle, 240 minus 180 is 60. I'm going to use my hand trick to model. Put away my 60-degree angle, that's my ring finger. If I want secant, then I want cosine, which is on the left of that angle. So I have square root 1 over 2 or 1/2 for cosine. Flip it, that'll be 2 for secant, and then all students take calculus. In quadrant 3, where 240 is, secant would be negative. So then it's negative 2. But that's a lot more work than just knowing the unit circle, right? So we won't go the route of I know the unit circle. See if you could do this one for me. The cotangent of negative 13 pi over 6. Remember, unit circle is really the route we want to go. It's going to be the easiest route. How can you use the unit circle? If the angle that you're calculating without a calculator is not on the unit circle, what should you do? Find a coterminal angle that is on the unit circle, right? They're going to be the same angle. So I should begin by adding 2 pi, which 12 pi over 6 is the same as 2 pi. Well, that'll get me to negative pi over 6, but that's not on the unit circle, so I'm going to add 12 pi over 6 again. So calculating the cotangent of negative 13 pi over 6 is the same as calculating the cotangent of 11 pi over 6. Now, if you're using your unit circle, tangents we just recorded in quadrant 1, right? So this cotangent of 11 pi over 6 is going to have the same value, positive or negative, could change, as pi over 6 in quadrant 1. So we'll have to work through tangent, right? What is the tangent of pi over 6 in quadrant 1? Radical 3 over 3 is pi over 6 tangent. What's the reciprocal to radical 3 over 3?
Radical 3.
Just radical 3. So I know that I've got a radical 3 at least, and then I have to decide if it's positive or negative when I'm doing tangents. All students take calculus. This one is in quadrant 4. It should be negative. If you're doing this without a calculator and you get stuck, could use your hand trick. You could find the reference angle. It's going to be pi over 6, right? It's negative 13 pi over 6, so it's going to be pi over 6. Put away the pi over 6 angle. And if you're using the hand trick, flip your hand. Its tangent will be the square root of your fingers over the square root of your fingers from left to right. So cotangent will be opposite from right to left. So square root of 3 over square root of 1. Square root of 3. All students take calculus, it's negative. Okay, last thing, and this part will be really great on your homework to help you learn your angles on the unit circle. Okay. So the directions here on this section of the homework is going to say, find the two angles that satisfy this equation. If I say that the sine of theta is equal to negative square root 2 over 2, the angles, it will just have less than 2 pi, I'm guessing. So you would say 0 and not 360, not 2 pi. If you're trying to answer this question, on the unit circle, what's equal to sine? The y's. So now look around on your unit circle. What angles, tell me, have y's that are negative square root 2 over 2? Give me degrees. 225. And 315. They're going to be the two angles. If you think about y being negative, they're going to be the two angles in quadrant 3 and 4 because you got to go down for y. Okay. And then also list those in radians. That's 5 pi over 4 and 7 pi over 4. So these are going to be good exercises for you to get used to your, like, all the angles on the unit circle. Which ones pair up with which. Okay. I'm going to hand back your quizzes and the quiz correction sheet. But while I'm doing that, I want you and your group members to see if you can use your unit circle to answer these. And I'll put my answers up at the end so you can check that.
How did she? The first one. So you have to think about like how much students in calculus. And so it's sine. So sine would be negative in 3 and 4. And then radical 2 over 2. The reference angle is 45. So then you have to look at the angles and that correspond in 3 quadrants 3 and 4.
Okay, is there any well, I'm going to, did you look at the formula in your notes yet? If you haven't looked at that, look at it first and then ask me. Anybody else? Case, did you want a correction sheet?
Yeah.
Anybody out here need corrections? Correction?
What was the whole students calculus?
Oh, it tells you what's positive and negative. So all of them are positive here, none are negative. Students stands for sign, and then of course it's reciprocal, cosecant. They're positive, everything else is negative. Take, tangent, cotangent are positive.
But it's like, is it gonna be this one?
Calculus, cosecant.
But it's like, so that we all.
Okay, so I'll talk about quizzes here in just a second.
You know what I'm saying?
Tangent undefined, your theta should be 90 and 270. That would be pi over 2 and 3 pi over 2. When I'm doing these last two, I probably think about them as their reciprocals. What angles have cosines of 1/2? That'll be pi thirds and 5 pi thirds, which is 60 and 300. And then same thing for cotangent. I would think about the tangent then, its reciprocal value will be negative square root 3. So tangent of theta equals, tangent is negative in quadrant 2 and quadrant 4. And those are the two angles, 120 and 300, that are the 60-degree angles. They're on that same butterfly at 60 degrees. And that would be, 2 pi over 3 and 5 pi over 3. So just a quick word then also, your homework on your gold sheet for your quizzes. Your quizzes are going to be due at the beginning of class tomorrow, so if you want credit back, have them done before you get here. If I wrote the word careful on any problem, it usually means something about mode. Either your calculator's in the wrong mode, or like you put an angle in degrees when the angle needed to be in radians. So it's usually something small about the value of the angle or your calculator. The only thing I ask on corrections, please do them in numerical order. So like put the first one that you missed up at the top. Then the other. If you put them in the correct boxes, that's fine. Just don't do number 6 and then number 3 and then number 2 out of order.